Hello there, this is Arun and welcome back. We know that platform independence is one of the key benefits of Java. But before I understanding how Java achieved platform independence, we need first to understand what platform dependency is and to understand platform dependency. We also need to know what compilation is very fundamental concept in computer science. And if you are new programming cannot and not completely sure about what it compilation is, then this is short. Discussion on compilation should be very helpful, but if you are already familiar with programming and clearly understand what compilation is, then feel free to skip this lecture. Let's start with absolutely basic concept of a computer. Every computer has a fixed set of instructions that it understands, and collectively they are referred as the instruction set of computer. So the CPU would understand these instructions, and a computer program is made of some of these instructions. That is the instruction here. A computer program to perform something meaningful. Each instruction tells the CPU to perform certain actions, and each instruction is basically a sequence of zeros and ones. That is an instruction as binary format. Such such instruction that computer understand is called is as machine language. That is the language which a machine understands, just like the way we human understand our languages. Machine language is also referred to as machine code and is sometimes also referred as native language. And here is example machine instruction which perform additional operation. The six digits right specify that it has an add operation. Now, a computer program would involve many such instructions, and absolutely wo- it would be very frustrating for someone to write and also read such instructions which have only zeros and ones. So it is very confusing, and it is what to be so similar than this. So computer scientists came up with another language called assembly language, which is much more easier to read and write. And here is an example to add two numbers, which is much more expressive than the machine code. So assembly language provides certain higher level notations for write instruction like add in this case. But computers understand machine language. They don't understand assembly language. So there is a program called assembler that translates assembly language instruction into machine language instruction, which a computer can understand. Both machine language and assembly language is referred to low-level language. So, um, so and because they use low-level details of computer. One example would be specifying memory location, where we are storing data, but writing programs, even in assembly language, is still tedious. So, programmers wanted programmers programs to be expressed is in a more easier way, and they also wanted to hide low-level details. So in the time they came up with high-level languages, and some example high-level languages include Fortran, C, C++, and C Sharp, and they use English like words like public, private, and so on. mathematical notation like plus and minus, and punctuation to write programs. So they are much more easier to write and read. As well we will see in this course. And here is an example Java program. As you can see, it uses English words like public and addition operation here using the symbol plus and punctuation here in the form of semicolon. And of course, they also hide level the details of the computer. So today we mostly use only high level programming language. Assembly language is not used very much and used only where performance is critical, like in the case of operating system of electronic devices. And with the in terms of terminology, source code is the term that is used to refer any code expression the programming language. So source code is nothing but programs we write like the Java program and that we see here. And many times in this course I would be using that term source code. Now, like in this case of source, that a language source code cannot also be understood by a computer. So we need to translate source code into machine language, and that is where compiler comes in. So translation from source code to machine code is done by this program called compiler machine. For which the executable program is then executed directly by the CPU in separate system. So compilation and execution they are two different steps. First, compilation is performed in order to translate source code into machine code and then separate. The machine code will be executed. Now note that this illustration we are calling the translated language as target language or not. Machine language, this is we say that is because in some case it may be something else too. For example, in this case, C or C++ target language will be machine code. However, Java is Java bytecode, which will be discussed later. Sometimes target language can also be another programming language. For example, Closure script is a language, and it comes with compiler which compiles Closure script programs into JavaScript, which is a different language. Such compilers are also referred to as source-to-source compilers or trans compilers. Source-to-source because it is a converting one source code into another source code. And there are some core operations that compiler for performs. And let's see what these are. Verifying syntax and semantics of the source code or of one of them. And this is on code compilers with the rules of programming languages. For example, a program is made up of statements, and in this case of Java, every statement must end with a semicolon. So that is the rule of Java programming language. And if a if statement doesn't end with a semicolon, then compiler detects a syntactic error and reports into the developer. For example, there is statement in Java that prints the text although and as you can see the statement ends semicolon. And if you omit the semicolon, then compiler reports that it has syntax error. Semantics is about meaning. For example, in Java we write our programs as classes and the class can also have something called a subclass, which is just another class, but a specialized version of the original class. But if we declare a class with keyboard called finder, then the compiler ensures that that the class cannot have subclass. So if we happen to define a subclass, then the compiler reports receive error. So that how the compiler is ensuring that semantics associated the final keyword is being respected. It is not being violated. Compiler also performs certain code optimization for faster execution of the program. Some sudden compilers do that. And finally, it generates machine code from the intermediate optimized code. So the optimization is done and then machine code is generated from that. A compiler very complex program and this code operation or basic operation that any compiler support. And you will see in this course Java compiler performs tons of additional operation to ease the program is lost. So the compilation program process can be slow due to the complexity in translation. However, once compiled machine code execution will be very fast and the machine code can be executed anytime and any number of times. But any change of source code requires completely decomposition. Next, we will look platform dependency, which will also give you an idea on how C program is compiled on Windows and Linux machines. We are not going to write any code for discussion, but towards the end of chapters we will write, compile and execute our first program. So in this chapter we will write only and one program. But as the course progresses, starting from the next section, they will write lots of programs. So that's about it. Thank you. And next we will look perform platform independence.